Alzheimer's and the brain's Butterball cells. It's a funny nickname, but it paints a surprisingly accurate picture of what's happening inside our heads. Microglia, the brain's immune cells, are normally lean, agile, and endlessly busy patrolling neurons, clearing misfolded proteins like amyloid beta and keeping the neural environment in balance. But in Alzheimer's disease, these cells start hoarding fat, filling up with lipid droplets that slow them down and impair their ability to do their job. Suddenly, your brain's once tireless janitors resemble tiny butterballs, round, overstuffed, and not quite moving at their usual energetic pace. The cause of this transformation is an enzyme called DGAT2. Think of DGAT2 as an overeager pastry chef constantly producing triacylglycerol, the storage form of fat. In a healthy brain, DGAT2 helps microglia store energy safely for later use. But in Alzheimer's, it lingers too long, generating more fat than the cells can manage. The result is microglia that are literally weighed down by their own lipid hoard, particularly those near amyloid plaques. These Butterball cells clear significantly less amyloid beta than lean microglia, allowing plaques to accumulate and creating a neural environment that promotes further disease progression. The positive news is that this Butterball status isn't permanent. Researchers at Purdue University discovered that by blocking DGAT2 or encouraging its degradation, microglia could shed their excess fat, regain mobility, and resume clearing plaques efficiently. The previously sluggish janitors spring back into action, reducing inflammation and restoring neuronal health. In other words, even the chubbiest Butterball cells can slim down, get back on the treadmill of brain maintenance, and perform their vital functions once again. This discovery is significant because it reframes Alzheimer's from a story of inevitable decline into one of metabolic imbalance that can be corrected. Instead of just targeting plaques directly, we can empower the brain's own immune system, giving microglia the tools they need to defend neurons naturally. By preventing or reversing fat overload, the brain's defense crew can maintain its efficiency, potentially slowing disease progression or even preventing it from taking hold. The implications extend beyond Alzheimer's. Fat accumulation in microglia is also observed in normal aging and other neurodegenerative conditions, suggesting that strategies targeting lipid metabolism could broadly preserve cognitive function. Keeping microglia metabolically fit and lean ensures they can continue cleaning debris, regulating inflammation, and protecting neurons for decades. In other words, avoiding the Butterball state may be a key factor in preserving long-term brain health. There's also a playful, relatable aspect here. Microglia aren't failing because they're broken. They're simply overstuffed, like anyone who's overindulged and needs a reset. The term Butterball cells gives a humorous, human touch to a complex scientific concept, making it easier to understand and remember. More importantly, it underscores a hopeful message. These cells can recover. With the right interventions, they can shed excess fat, regain their energy, and return to their essential role in maintaining a healthy brain environment. So yes, Alzheimer's may create Butterball cells, but they are far from hopeless. Targeting DGAT2 and lipid droplet accumulation shows that even the heaviest microglia can slim down, restore their activity, and resume clearing plaques. The brain's immune system is resilient, and with the right support, it can bounce back, protecting neurons and preserving memory. The story of Butterball microglia isn't one of defeat. It's a story of recovery, resilience, and the remarkable adaptability of our own cells.